Good morning, all. A very warm welcome to Cloud Day Developer Keynote. Thanks for taking the time and joining us today at the Developer Playground track of Oracle Cloud Day. My name is Manish Kapur, and I'm from the Oracle Cloud Platform for Application Development team. Over the next 1 hour or so, I will be introducing you to the Oracle Application Development Cloud Platform and then spend some time talking about building intelligent cloud native applications. Before I begin, here's the safe harbor statement from Oracle. Right now is the golden age for developers. We are in the middle of an explosion of technologies for developers. They have a choice of languages, frameworks, platforms, and much of this is fueled by the developers themselves via open source software. The ability to solve problems quickly and reliably has increased exponentially over the last several years. And why is this? In a sense, it has been always easy for developers to write code. What is different now is the possibility of architecting a new generation of end-to-end solutions quickly. One of the major factors that has really opened this up is both the availability and stability of public cloud environments. It's now possible to get the compute and data management required for even the most complex solutions within minutes. And that means that the barrier to adopting new technologies is disappearing. The cloud is opening up new paradigms for applications as well. We'll look at some of these examples today. One of the major innovations we are seeing is the emergence of intelligent cloud native applications. Intelligent because it involves integrated artificial intelligence within the applications themselves. This has some major implications for application development. In particular, developers need to start thinking differently about data and data management. Applications are no longer just about CRUD operations on databases. They are being driven by the knowledge that is embedded within the data. To do this right, to make it maintainable, and to ensure that the machine learning models are driving appropriate decisions, the applications need to be cloud native. We will talk about why in this session today. In the early days of cloud computing, applications were built and run directly on physical servers. Next, we saw the emergence of virtualization and started seeing consolidation of servers and better utilization of resources. In the cloud computing era, which started about 15 years back, it was all about distributed and elastic computing for applications. Containers and serverless further exploit the benefits of cloud's distributed and elastic computing properties. This shift is all about making developers more agile and productive by having them focus on writing code and not worrying about setting up and managing the underlying infrastructure resources. We can trace the evolution of how companies have developed, deployed, and managed applications over three distinct phases. In 80s and mid 90s, there were data centers with physical servers running monolithic applications developed using traditional waterfall methodologies. Going into late 90s to 2000s, data centers and hosting providers were running Linux or Unix servers with virtual machines running end-tier applications that were developed using agile methodologies. And from 2010 to now, cloud has been increasingly replacing the data centers and hosting. Modern applications are being developed as microservices running on containers. Developers and operation teams are collaborating using DevOps methodologies. In fact, with serverless functions, we are seeing it move to a no-ops model. We see a new generation of applications that are born in the cloud and will only be running in the cloud. These are the cloud native applications that follow the cloud native computing foundation's guiding principles. Oracle has a strong portfolio of products to help you build intelligent cloud native applications. Today, I will introduce you to the Oracle Application Development Cloud Platform and also show you a demo of building and deploying a cloud native application. So, what does it take to build and deploy cloud native applications? Let's talk about a typical high level workflow. Developers write code using their favorite IDE, language, and DevOps toolchain of their choice. They then package that code and all the dependent libraries and binaries into a Docker container image. Push this Docker container image into a repository which is called a container registry. Use Kubernetes platform to deploy images from the registry to worker nodes inside the cluster. The software running on these nodes is typically deployed as microservices or as serverless functions. These containers can be spun up and spun down very quickly compared to a virtual machine or an operating system on a bare metal. Each microservice is independent and loosely coupled to other microservices. Each can scale independently. Each microservice manages data, typically inside its own database. This can get challenging when there are many microservices and databases all over the place. We'll talk about this in some more details in the upcoming slides, but this is how, at a high level, modern cloud native applications are built. We are also seeing a new breed of modern applications that are using machine learning to provide suggestions and predictions for better user experience and to drive business decisions. This trend is very real. Let's look at some examples of applications that are driven by machine learning models today. Medical diagnosis. At Oracle Open World last year, we built and demonstrated a machine learning based application for pneumonia identification. Artificial intelligence can often give better diagnostic results than human beings for this type of problem. Smart agriculture. This example is from AgroScout, an Israeli startup who uses Oracle Cloud. They use images from low-cost commercial drones to do early detection of crop diseases and pests at the level of individual plants. It's far more accurate and cheaper than using planes or satellites. Oracle SaaS applications have several examples as well. Machine learning is embedded into Oracle HCM Cloud to sift through resumes to identify the best candidates. Machine learning models can also recommend career progression paths for employees. Oracle Customer Experience Cloud uses machine learning to recommend best offers for sellers to make to a customer based on what other products they own and other data. Machine learning can also rank the best target accounts for a given product and improve the sales forecast accuracy. Oracle has three core avenues to build AI-powered applications in our cloud. Where we are differentiated is that our entire stack is integrated and designed for the end-to-end workflow of building AI-powered applications, from data management to data science to application development. The first solution for machine learning is for data science teams who need a collaborative workbench, which is the Oracle Cloud Infrastructure Data Science Cloud Service. This is a project-based environment that enables your teams to collaboratively build, train, and deploy machine learning models into the applications. Second, for customers who have adopted our cloud database, like Oracle Autonomous Database, or even our big data services, we offer a number of machine learning notebook options which come packaged with those services. So you can run machine learning workloads on top of the database or the big data platforms with access to data stored in Oracle Cloud Infrastructure as well. Oracle Machine Learning is a development environment that uses a web-based interface to enable you to perform data analytics, data discovery, and data visualizations. Third, you have the option to architect your own machine learning platform on Oracle Cloud Infrastructure using whatever flavor of open source tools you prefer, or leverage our partner innovations from NVIDIA, H2O.ai, or others that are offered in the marketplace. Finally, Oracle offers a range of integrated services for container native, cloud native, low code, and mobile application development with end-to-end support for machine learning model APIs so you can build new intelligent cloud native applications or add intelligence to existing applications. Let's look at building machine learning models and then using them in your application. This is where our data science service comes into the picture. First, data scientists need to be able to find, explore, and understand the data sets that are available to them. As they're working through the data, one of the main tasks they have to work through is feature engineering. We're selecting, scaling, and forming the data in ways that optimizes it for input to algorithms to build machine learning model. Oracle Data Science Platform can help make this task very easy and successful. Training models is not a one-time event and often requires specialized hardware. We have seen many cases where models on conventional CPUs took weeks to train a model, but with GPUs, it only takes a few hours. Having a modeling environment with access to the right hardware on demand is key. Third, once the models are built, they need to be easily deployed. This is surprisingly a very hard task for companies that are not using a data science platform. Often models are sent to developers to recreate, which is error prone and tedious. It also leaves gaps for security and governance. Lastly, models are only as stable as the data. If datasets evolve over time, which is almost always the case, the model can become less effective or even incorrect. A runtime platform to monitor production models, detect decline in efficacy of the model, and to quickly retrain and redeploy is absolutely essential. All these tasks can be performed using Oracle's data science service. Open source is the hub of innovation, and we at Oracle realize this. Over the last 4 or 5 years, we have adopted open source software in a big way. We have taken 4 key steps. First, we are providing open source based cloud services in Oracle Cloud like the Managed Kubernetes Service, Serverless Function Service, Hyperledger based blockchain platform, and many more. Second, we are using and support open source standards based technology stacks in Oracle Cloud. You can bring any open source framework or software and deploy and run it in Oracle Cloud. Not only do we have open source based services and support open standards, we are also actively participating and contributing source code in open source communities. Oracle is a platinum member of Cloud Native Computing Foundation. We are a big Linux open source contributor too, and we'll continue to increase our commitment and investment into open source software. Oracle's application development platform is built on top of the second generation cloud infrastructure called Oracle Cloud Infrastructure. It provides bare metal, virtualized, and containerized compute. We provide GPUs for performance intensive workloads such as artificial intelligence and machine learning workloads. We also offer a wide variety of cloud storage options like block, object storage, file storage, and archive storage. Oracle Cloud Infrastructure offers a fantastic array of services for developers building modern cloud native applications. As a developer, you have the choice of using any programming language and framework: Java, JavaScript, Node, Python, Ruby, etc. You can use any developer and DevOps toolchains as well. We provide a set of free tools called Developer Cloud, but you can also use the ones that you're already familiar with. Using these developer tools, you can build all kinds of applications like cloud native applications, low code applications, mobile and conversational interfaces, and many more. We offer low code platforms such as Oracle Application Express and Visual Builder to make it very simple for developers and citizen developers to create applications with little or no programming. We have services for building mobile applications. For conversational interfaces like chatbots, we have the Oracle Digital Assistant service, which is based on artificial intelligence and machine learning. You can also embed machine learning into your applications using our data science cloud service that we just covered. We offer a set of cloud native services based on best of open source technologies, including the managed Kubernetes service, a container registry, and many more. We provide a managed Terraform service called Resource Manager. We also have a serverless functions-based service which is based on the open source FN project. And for all the applications that you build, there is an integrated data platform. This includes a flagship Oracle Autonomous Database, but we also offer a choice of other databases. For example, MySQL Server, NoSQL Server, and we also started offering Microsoft SQL Server. We also provide a serverless Apache Spark service called Dataflow for big data workloads, an Apache Hadoop service, and a data integration service. There is a data catalog to manage your data assets across both databases and cloud native storage. Finally, we provide a number of services to help you manage and secure all your applications. So as you can see, we offer an end-to-end set of services for developing, deploying, and managing applications. Let's look at some of the services we talked about that are part of the Oracle Application Development Cloud Platform, and begin with the low-code development services. For low-code development, Oracle has quite a few options. First one is the Visual Builder service. Visual Builder enables you to rapidly create and host web and mobile applications with minimal coding required. This service is primarily used for extending Oracle SaaS applications. It uses a drag and drop browser-based visual development approach for building applications. Users can visually create an application using a collection of built-in user interface controls and bind to the UI to existing REST services or custom business objects they create from within the tool. The applications you create can be published with a click of a button to provide access to end users. Visual Builder is an easy-to-use cloud-based service that is available as a standalone service and also included in the Oracle Integration Cloud. There is no software to install, and you can start building applications and extending Oracle SaaS applications just using a browser. Behind the scenes, it creates JavaScript code for your applications. We have lots of our Oracle SaaS customers using this service to extend their SaaS applications. Another low-code solution that we have is Oracle Application Express or Apex, which is extremely popular among developers, and there is a big global community for this platform. Oracle Application Express is a low-code development platform that enables both citizen developers and professional developers to build scalable, secure, data-centric apps quickly that can be deployed anywhere. Oracle Apex is included with Oracle Database as a no-cost option. It can run anywhere where you have the Oracle Database running, on-premise or in the cloud. In June of 2019, we announced the availability of Oracle Apex as part of the Oracle Autonomous Database. Oracle Apex on Autonomous Database provides a pre-configured, fully managed, and secure environment to both develop and deploy world-class data-centric applications. Oracle takes care of configuration, tuning, backups, patching, encryption, scaling, and more, leaving you free to focus on solving your business problems. Apex comes included with both Oracle Autonomous Transaction Processing and Oracle Autonomous Data Warehouse. You can simply get started with Oracle Apex by spinning up an instance of Autonomous Database using the Oracle Cloud free tier. It just takes 5 minutes to get going and start developing low-code applications on Oracle Cloud using the Autonomous Database. Let's now talk about Oracle Digital Assistant, which is another low-code development service in Oracle Cloud. It helps you build conversational interfaces for your business using AI and ML. Think of it like what Siri and Alexa do for consumers. Oracle Digital Assistant does that for business use cases. This slide shows the natural evolution of how we use and experience applications. Historically, the world of technology had multiple tipping points, that have fundamentally changed our lives. Mark Anderson helped give birth to the World Wide Web via the Netscape browser, which eventually connected billions of computers. Steve Jobs introduced the iPhone in 2007 and pretty much put a smartphone into the pockets of billions of people. The iPhone effectively put a computer in every pocket. And now, these days, we are seeing the emergence of chatbots. Conversational interfaces like chatbots, Alexa, and Siri voice assistants are becoming parts of our daily lives. Till now, these conversational interfaces have mostly seen growth in the consumer space. But now we are also seeing conversational interfaces being used in business applications. And that is where Oracle Digital Assistant comes into the picture. Before we talk about Oracle Digital Assistant, let's look at the difference between a chatbot and a digital assistant. A chatbot is typically a single skill interface, whereas a digital assistant combines several skills to provide a more complete solution. For example, an air tickets booking chatbot or bot can be used to just book tickets and air tickets only, whereas a digital assistant can be created to include multiple functions or skills or bots. For example, a travel digital assistant service can include an air ticketing bot, a hotel booking bot, and a car rental booking bot, all included together into a single digital assistant. Oracle Digital Assistant provides you with platform and tools to easily build AI-powered assistants that connect to your backend applications. With Oracle Digital Assistant, you can develop assistants with skills that can benefit from a more natural conversational interface through text or through speech to your enterprise applications. By using artificial intelligence, natural language processing powered by neural networks and machine learning, Oracle Digital Assistant can easily detect what the user is trying to achieve and respond appropriately with information or results of transactions from API connections to any of your backend enterprise applications and information sources. The platform makes it extremely simple and easy to build and train your digital assistants without the need for specialist artificial intelligence or machine learning skills. Your digital assistant can then be exposed through many interfaces like a chat interface or a voice channel or a custom mobile app or even your website. Oracle Digital Assistant is the only enterprise digital assistant in the market that offers pre-built API-trained enterprise skills across several business applications like ERP, CRM, HCM, and e-commerce. It offers an open and extensible platform to integrate with third-party bot AI APIs as a provider or as a consumer. And it offers the only enterprise configurable voice for true business conversations. You can train the voice with domain-specific vocabulary. Let me show you a demo built using Oracle Digital Assistant integrated with a backend HCM application. As you will see from this demo, Oracle Digital Assistant created voice interfaces can understand complex business terminology and respond to changing contexts using a series of different skills.
What does my day look like tomorrow?
You have a meeting with Fancy Cosmetics tomorrow from 9:30 to 11 a.m.
Send me the details of the last two meetings. Do we have any referenceable customers using Autonomous Database in retail?
Sure, here's the list of retail customers using Autonomous Database.
Who did we compete with for Elemental Design, and what was the deal size?
The competitor for Elemental Design was Amazon, and the deal was worth $720,000.
What accounts does Bob have except Elemental Design that use Autonomous DB?
Bob has the following accounts using Autonomous Database other than Elemental Design.
Send the win report for the second one to Chris.
Next, we'll talk about cloud-native application development. The most simple definition of cloud-native application is an application developed using cloud-based technologies. A more technical and commonly accepted definition is from Cloud Native Computing Foundation, or CNCF. CNCF has made available a trail map which shows the recommended process for leveraging open source technologies to build cloud-native applications. Per this trail map, cloud-native applications are built using containers, use CI/CD, consist of microservices architecture, and use distributed management and orchestration. This slide shows a simplified view of the life cycle of cloud-native applications. Developers can choose any programming language and framework of their choice to build cloud-native applications. It all starts with writing the code and using a source code repository like Git or GitHub or Bitbucket. This application code is then built and deployed using a CI/CD toolchain like Jenkins or Oracle Developer Cloud Service. The build is packaged as a container image and pushed out to a Docker registry from where it gets deployed into a Kubernetes cluster. Next, you test the application using tools like Selenium or JUnit. The Docker images that you build can be scanned using image scanning tools before they are deployed into production. Once the applications are deployed, you monitor those applications using tools like Prometheus and Grafana. As you can see, this is an entire lifecycle of application development. Oracle Application Development Platform gives you all the underlying development services to seamlessly develop and follow DevOps methodology for building cloud-native applications. Let's map the Oracle Cloud Services to the development lifecycle of cloud-native applications. Oracle offers a fully managed open source based Kubernetes service called OCI Container Engine for Kubernetes. This is an unforked CNCF certified managed Kubernetes service for orchestrating your Docker containers inside the cluster. One of the unique differentiators for Oracle Kubernetes Engine is that this service can support Kubernetes cluster node pools running on both bare metal compute and virtual machines. This means you can have a pool of nodes for running CPU-intensive workloads on bare metal compute and another pool of nodes in the same Kubernetes cluster running on virtual machines. Oracle offers a complete cloud-based development service called Oracle Developer Cloud. This includes source code control using Git, issue tracking software, wikis for documentation, a CI/CD subsystem for building and deploying Docker images. The Docker images that you build for your applications can then be stored in a Docker registry, which is Oracle Cloud Infrastructure Registry. Oracle Cloud Infrastructure Registry is a Docker-compliant public and private registry with access control and is integrated with both Oracle Kubernetes Engine and the Developer Cloud Service. The images of the cloud-native applications that you build using Developer Cloud Service can be stored on Oracle Cloud Infrastructure Registry and then deployed into Oracle Kubernetes Engine automatically using DevOps methodology. Oracle Functions is a serverless functions managed service that is based on the open source FN project. It is a completely managed service built using open standards. As it is open source based, there is no vendor lock-in. You can use the open source FN project on which this service is built and deploy the open source software anywhere you like. In addition to this, we support several cloud-native services and technologies like Service Mesh for your microservices, API gateway, events, streaming, and notification services. Oracle provides pretty much everything that you may need to build and deploy modern and intelligent cloud-native applications. Historically, developers built large monolithic applications using one data store. These applications and data stores become difficult to maintain and unresponsive to change over a period of time. This led to an alternative approach, one with microservices and specialized databases like MongoDB and Cassandra. Each microservice with its own database is a pattern that started emerging. Each database is specialized for a workload or data type like document type, key value, analytic, relational, graph data types, etc. These specialized databases provided independence, thereby making it easier to adopt microservices. This has been the typical design pattern for microservices up until recently. We have seen customers who went down this path were successful when the number of microservices was less. But as and when you create more and more microservices, each with its own database, it quickly becomes a very complex and very difficult to manage, especially from a data management perspective. Imagine if you adopt microservices architecture and over a period of time, you develop hundreds of microservices, each with its own database. This becomes quite a complex distributed architecture that leads to several challenges. Each single purpose database that is deployed fragments the overall data architecture. Each single purpose database has different operational needs and limitations, requiring unique management and skills. Data propagation becomes inherently difficult and causes unavoidable data delays and data divergence. Separate security policies must be implemented in every database and must be re-implemented when apps or policies change. High availability and scalability mechanisms and configurations are specific to each single purpose database. All of these factors make database management for cloud native applications very hard. Integrating fragmented databases to create a complete, available, secure, and scalable solution is a complex and difficult task. Customers who went down this path are now changing their views. They are now looking for a more simplified architecture and one that does not increase complexity and management costs. Oracle and some other companies have recognized this need and have come out with a multi-model database that radically simplifies data management for cloud-native use cases. Oracle multi-model database included in Autonomous Database simplifies and makes the life of developers very easy. It is a converged multi-model database that can address all the development needs of developers. Oracle Database 19c and later support data formats, access methods and indexes, and programming languages required by specific workloads while exploiting common administration, security policies, and transactional and data consistency. It includes an in-memory columnar store, a sharded database model, as well as a document store, spatial database, and graph database. This multi-model approach simplifies data integration across multiple data formats. Oracle Machine Learning included with Oracle Database can help developers build intelligent apps. Oracle Database is a converged multi-model database that helps simplifying the data management challenges associated with microservices. In this slide, you will see that using Oracle Autonomous Database, the challenges associated with database sprawl, management, security that we talked about are addressed and resulting in a much simpler architecture. Each microservice still has its own database, but using Oracle Database, you can have one pluggable database for each microservice. Each pluggable database can store different data types as per microservices needs like JSON, relational, graph, document, etc. With this architecture, you don't end up with dozens of different databases requiring different skill sets to manage and operate them. Oracle Multi-Model Database included in Autonomous Database simplifies and makes the life of developers easier. It is a converged multi-model database that can address all the development needs. Oracle Database 19c and later support data formats, access methods and indexes, and programming languages required by specific workloads. It includes an in-memory columnar store, a sharded database model, as well as a document store, spatial database, and graph database. This multimodal approach simplifies data integration across multiple data formats. Oracle Machine Learning included with Oracle Database can help developers build intelligent apps leveraging machine learning and advanced analytics. Developers also find ease of access with CLI and REST API very useful. And most importantly, as it is autonomous, it is a self-driving database that is completely managed for you. You do not have to worry about tuning, securing, patching, and other administrative operations that can take up a lot of developers' time. It also comes with built-in tools like Developer Workbench and modeling through SQL Developer Web and the low-code Application Express platform. Here is a high-level architecture of how it all looks like if you are building microservices using Oracle Cloud Native Solutions and Autonomous Transaction Processing Database. Starting from the left-hand side, as a developer, you start writing your code using an IDE and push that code into a source code repository like Git in Oracle Developer Cloud. Oracle Developer Cloud also includes Jira issue tracking functionality, CI/CD toolchain, and helps you automate your build and deployment steps. Once you have coded your application using Developer Cloud Service, you can build a Docker image of that application, push it to a cloud infrastructure registry, and then deploy that app into Oracle Kubernetes Engine. This approach can be used to build all your microservices. And with Open Service Broker for Oracle Autonomous Transaction Processing Database, you can manage the lifecycle of your Oracle database. Each microservice can be written using the language of your choice and can have its own pluggable database for storing different data types. And with Oracle Management Cloud and other open source services like Prometheus and Grafana, you can manage all of this setup very easily. So let me now show you a demo of building a cloud native application using Oracle Cloud Native Platform and Oracle Autonomous Transaction Processing Database. This slide shows you the high-level architecture of the demo that I'm about to show you. Before we see the demo, let's look at this architecture. So as a developer, you can develop new microservices inside the IDE of your choice. Once you have developed the source code of your application, you can push the code to any source code repository. In my demo, I'll be using Developer Cloud Service, which also includes the CI/CD toolchain for me. Once I have the application coded, the Developer Cloud Service will trigger a build job, which will build and push out the Docker image for my application into Oracle Cloud Infrastructure Registry. Once the image has been pushed out, the CI/CD toolchain will automatically push out that image and deploy it as a container inside my container engine for Kubernetes. And this microservice that I have developed uses Oracle transaction processing for storing the data. So in my demo, I already have a Node.js microservice which is deployed in my Oracle container engine for Kubernetes, and it's already configured with the Oracle Autonomous Database. What I will show you is how CI/CD automation is implemented. So as soon as I make a source code change in my application which is deployed in Kubernetes engine and push out that source code into Git in Developer Cloud Service, it will automatically trigger a rebuild of the Docker image. It will create a new Docker image and push it out to Oracle Cloud Infrastructure Registry. Once the image has been pushed out to Cloud Infrastructure Registry, the updated image will then be deployed into Oracle Kubernetes Engine. Let's see this in action now. So here's the source code from my microservice application, which is written in Node.js. For this demo, what I will do is I will change the logo of the application. So before we do that, let me show you the application itself. So here's the microservice application that is currently running. It's a simple web store where you can buy and sell articles. So this store is called A1. As you can see, it has the logo over here with a red O. Let's make sure it's running. Let me reload the page. So I have the network connectivity and it's running fine. Before I make changes to the application, let me show you the Oracle Cloud Console. So this is the Oracle Cloud Console. On the left hand side are all the services that are available in Oracle Cloud. So let me show you my autonomous transaction processing database that I'm using for this application. So I have a database here which I've already created. It's called MicroATP. This is the database that I'm using for my microservice that is already deployed. And here I have a Kubernetes cluster which is also already deployed in which my application is running. So let me show you the Kubernetes cluster. So it's part of Developer Cloud Service. So I go to the Oracle Kubernetes engine and I have a cluster here. This is the cluster which I'm using. This cluster is running version 1.14.8 of Kubernetes, as you can see. And it has a node pool which has got 3 nodes in it. So let's look at this node pool and see the 3 nodes. So if you look at the nodes here, these are 3 nodes, 3 virtual machines, 1, 2, and 3. They're all spread across 3 availability domains. Availability domain 3, 1, and 2. These are the 3 nodes which are part of my cluster. Here I have the cloud infrastructure registry as well. In this repository is where I am storing my Docker images for my node.js microservice application. Okay, and let's now take a look at the developer cloud service. So if you look at platform service, under that we have the developer cloud service, and I can access the instance here. So inside developer cloud service, I have several projects. Each project can be a separate microservice. And there's an organization concept. Inside the organization, you have separate projects, and each project can be an application of its own, right? So I have this microservice ATP application, which is the one which I'm using for my demo. When you click on it, you will enter the project home where you will see the list of activities associated with that project that are happening. So last build which I had run was build 54, which was about 8-10 minutes back. Here I have the Git repository for my application, microservice application. As you can see, the source code is here, right? And then I have build jobs here associated with my microservice. There are 2 build job steps. One is create a Docker image for the node.js microservice. And second is to deploy that application into Oracle Kubernetes engine. This can be a pipeline. So as you can see, I have a pipeline called build pipe A1, and it has 2 steps. It's a very simple pipeline. First step is it will build a Docker image. Second step is it will go and deploy that application into Oracle Kubernetes engine. Let me reduce this windows. So let's go back to my application here. I have the images here. What I will do is I'll change the logo of my web store. So I'm changing the logo to with a new logo. Once I do that, I will run the git commands. So this is the commit change. You always put some comments in there. And then I do a git push. My source code here on my local laptop is already configured to push out to this repository in Developer Cloud Service. This is the instance name. So as you can see, the source code changes were pushed out to my Developer Cloud Service. So let me go back and show you the Developer Cloud Service interface. And if I click a reload here, I should see the new build job has already started. So you can see I did make a commit there called update logo. As soon as that happened, it created a new build of my new Docker image for my application, and then now it's redeploying that new Docker application. So let's go and look at the builds. So you can see the first one was just run. This is the build job for creating my Docker image, and I can look at the git log and build log and everything here. So you can see that the build was successful. It created a new image, and then you can go back and look at the deploy job, which is part of the pipeline. If you look at this build log, it is completed. Let's go and look at the deploy log, and here it is. It just now completed. So you can see it was completed fine and it was successful. And in the project home, it should say that the build job was successful, right? So I created a new Docker image and deployed it automatically as soon as the source code was changed. So now, if things went well, keeping fingers crossed, we should see this logo has been updated. Let's reload the page. And there you go. You see the new logo for my web store now. So to summarize, what I showed you in the demo was basically a CI/CD automation demo where I had a microservice already deployed. I made a small code change. In my case, I changed the logo of my web store. And as soon as I made the code change and pushed out the code change to my main branch in Developer Cloud Service, a CI/CD job was kicked off. The build pipeline consisted of two tasks. One was to create the new Docker image and push it out to Cloud Infrastructure Registry. And the second one was to redeploy that updated image. And you saw that everything happened seamlessly. So let's move ahead. So as you have seen from my presentation today, Oracle offers an end-to-end application development platform that helps you develop, deploy, manage, and secure your applications. This is offered via a set of integrated services built on top of a second-generation cloud infrastructure that addresses the complete lifecycle of application development. I will now end my presentation by recapping what was covered. Oracle's strategy for application development is based on 4 principles: open, modern, easy, and intelligent. Oracle Cloud is open and offers a choice across a range of technologies, including open source and third-party components. Developers can build any kind of application on Oracle Cloud and can choose any of the programming languages and data management strategies. Oracle Cloud enables developers to build modern applications using the latest technologies, architectures, deployment models, including serverless functions. Oracle Cloud makes it easy for developers to get started in minutes. Developers can use built-in platform functionality to avoid reinventing the wheel. And of course, Oracle Cloud enables developers to build intelligent applications powered by machine learning and advanced analytics. The platform is also optimized for HPC and data science workloads, and we build services like our data science cloud service on top of that optimized infrastructure. We think this is the best platform for developing intelligent cloud native applications, and we invite you to try it out today. Thanks for your time today, and I hope you learn more about how you can partner with us to transform your business using Oracle Cloud.